Earlier today, a damaging earthquake unexpectedly struck offshore of northern Japan, specifically 75 kilometers east-northeast of the city of Misawa. As the ground started to shake back and forth over a wide area, power outages were triggered and items fell off of shelves, resulting in more than a dozen injuries. Registering in as a major magnitude 7.6 earthquake, the event lasted for 30 seconds, and because areas adjacent to the fault which generated the quake moved by up to 4.3 meters or 14.1 feet, this displacement led to the generation of a tsunami. While initial reports suggested tsunami wave heights of up to 3 meters or 10 feet were possible, a less damaging tsunami was all that occurred, with maximum wave heights in one locality only being approximately 66 centimeters or 26 inches. Yet, for everything that this earthquake did do, you might be wondering, wait, why was the earthquake damage unusually light? The answer is that despite its high magnitude, this earthquake did not occur at shallow depths typical of a megathrust earthquake, which can generate far greater height-damaging tsunamis. Instead, it occurred at even deeper depths on a reverse fault solely within the subducting Pacific plate itself via what is classified as an intraslab earthquake. This great depth, specifically 44.1 kilometers or 27.4 miles depth, was unable to transfer much displacement to the surface, hence the only modest tsunami which struck. While U.S. Geological Survey modeling suggests that some landslides and liquefaction may have occurred in populated areas, there is now another potential problem. As a Megaquake Advisory was just issued. This advisory states that there is a temporarily increased chance of a magnitude 8.0 or greater earthquake striking somewhere in this approximate region, which, if such were to occur, would almost certainly generate a tall and destructive tsunami. Yet, they noted that the odds of such are still absurdly low, meaning by far that the most likely outcome is that no quote-unquote megaquake soon follows. So, if earthquakes can't be predicted in any form, why was this advisory issued in the first place? The answer is that any time a larger magnitude earthquake strikes, the chance of it being followed by a nearby larger magnitude earthquake temporarily increases, despite not being followed by such the vast majority of the time. The Japanese Meteorological Agency and other scientists have noted 3 megathrust sections of a plate boundary which have not generated a very large earthquake in a long time, which are deemed to theoretically have a higher than average chance in the next 50 years of producing a magnitude 8.0 or larger earthquake. Thus, whenever a magnitude 7 or larger earthquake strikes one of those particular areas, regardless of depth, a Megaquake Advisory is issued. Such an advisory was also issued after an August 2024 magnitude 7.1 earthquake in the Nankai Trough area, yet, as you might have guessed, no magnitude 8 or larger quake soon followed there. The advisory is not a forecast or warning, but rather is somewhat analogous to a fire weather warning, where a damaging fire could theoretically happen and strike your house regardless of the weather conditions, but is temporarily more likely to occur despite however unlikely this is whenever a fire weather warning is issued. So, ignore anyone who claims that this is an actual prediction, or those who wrongly claim this is related to the sun, auroras, solar flares, or space weather because these earthquakes are not related to such. Now, more aftershocks are likely to occur, although these should, statistically speaking, all be lesser in magnitude than the earlier 7.6 quake. As a final note, I would like to thank my new YouTube channel member Lilanaki1 for supporting my work.